because of this discontinuity, I can still solve my problem. But this is the technical way you have to do it. I have a discontinuity at 4/3. What do I want to do? I want to stop just short of it on the left, and I want to skip over just a little bit to the right. And, you know, you can't just randomly avoid it, right? So what do? You take limits. So now, because I did this, I can use the fundamental theorem in calculus because it's continuous. And then same here. On this interval, I'm now continuous. I can do the fundamental theorem of calculus. After you do the fundamental theorem, that's when you take the limit. So there is a way to do all this. These are called improper intervals. And you see it more in that 296. But it is something you always have to check. If you're going to do the fundamental theorem, technically as a shortcut, you're really always assuming it's continuous. Here I wouldn't have thought much of it, but then some of these negative numbers started scaling. If I have random negative numbers, I'm trying to plug into log. I need to be careful, because I know that has potentially domain issues. Alright. That was definitely the bonus question today. But anytime you apply a theorem, you really do need to check, does it actually apply? So it said it must be continuous. Because this one I can divide by 0, I need to be a little more careful on what I do. Right. Any other questions? But it's weird. For derivatives, if you had a discontinuity, you take derivative. Well, you can't talk about slope or anything, right? Here we can still talk about area. We don't care that we have discontinuities. We just have to make sure we set it up the right way to get the right answer. But technically, we can still do all the work. So going this direction is in some ways easier. I shouldn't say easier. It's more likely that you can do the work. Going towards derivatives, a lot of times you just have to throw out the problem and say, this one doesn't work, it's not differentiable. There's much more for that. Alright, so the other example I wanted to do today. Find the integral from 0 to 3/2 of 1 divided by the square root of 9 minus x squared. I'm focusing on some of the hardest ones right now. Technically, where is this? This one's continuous on -3 to 3. If I plug in 3, I divide by 0. Once I go past 3, this is a negative number. I can't take the square root. It is a technicality you should look at. We know all the problems we give you in this coursework because we didn't cover, when you take Calc B, this is a whole topic, so we would care and we want to check it. In this course, we're going to give you problems at work. But I know some of the notes or videos make a point of mentioning continuity, so I did want to at least say, why is that in there? Where's it coming from? But it's more, you should in theory be aware that likely not ever going to count off. Probably because I'll forget, because I know the problems have to work. Alright, how can I solve this problem? The big question is always, what formula do you want to shoot for and then make it look like that? Good. So what would be your end goal? Basically, what antiderivative do I want to shoot for? What is this maybe What does this look like the derivative of something, or at least close to the derivative of something? Arc sine? Alright, so you're saying shoot for arc sine. What does arc sine look like? The derivative of inverse sine is 1 over the square root of 1 minus x squared. Alright, those believably look similar to each other. So that gives me a target. It's clearly not this. So I'm probably going to need some type of substitution or chain rule. So what would this be if I do a chain rule?
Times v over dx of x.
So what am I really going to do? I want to make it look like this. This formula times some derivative, where this is the derivative of what I have here. If I can do that, now I know the antiderivative. And why did I choose to go for this? X squared or 1 minus x squared, that seems believable. I changed from 1 to a 9. And that looks like it has some promise. That's kind of that's how I was really thinking up there too. That looks like the derivative of natural log is 1 over something. That's what I had there. Now, can I do the same trick here? Is this one going to be a log? What's the big difference between the first example and this one? That square root with something squared in the difference really changes the problem. Yeah.
So, couldn't you do u is equal to x over 3?
Yes, that's what we're going to end up with. So, how do we get to x over 3? You mentioned it. Can we factor out a 9?
Oh, if both of them have a coefficient of 9,
I want to do this. To move that 9 over to the x. So why is that going to work? 9's perfect square, I get a 3 out here. Square root of 1 minus x over 3 squared. Yeah. Well, maybe. So I'm going to treat this as 0 to 3 halves of 1/3 times 1 over the square root of this. And then my claim is this looks a lot more like this setup, right? It's a 1 minus inside the square root and then something squared. Instead of x squared, it's u squared. So what do we notice about what is the derivative of x over 3? Because that's the part that matters, right? Here, if I put a u here, chain rule says I need to multiply by its derivative.
it's going to be
So I
1/3.
need to know what is the derivative here so I know what to go for.
1/3.
1/3? So if I replace x over 3 with the letter u, the derivative of that would have been 1/3. So where do I move this 1/3?
The outside.
In theory, I can always move the outside because it's a constant. But what does this say? If I want to use this, right? This part's already fixed. It's the x over 3 that I'm moving here. But that means on the right, I really need its derivative. So instead of moving the 1/3 to the outside, I would say you want to put it right here so that it looks more like a chain rule. Right? Can I, you move to the outside, do I know the antiderivative of this?
Arc sine of x over 3,
Almost.
and then times 1/3.
I need a 1/3 in there still, right? Or I need to account for that because of the chain rule part. So what I would say is make this the integral from 0 to 3 halves of this. And the reason I do that is so I can rewrite it as exactly a or chain rule. Right? If I can write it that way, that's exactly what this formula says, right? Instead of writing u prime, I should have probably written u dx. If I'm going to undo the chain rule, I need this to be the exact derivative of whatever I had inside here for the formula to work. So then now what is the antiderivative? I guess you already said it, right? Inverse sine of x over 3. And then I evaluate from 0 to 3 halves. So I couldn't make it just x. If it was just an x on the inside, I'd get this formula. Where's that 1/3 coming in? Because I had an x over 3 here, and I'm just putting x over 3 here. So I'm looking at it as this was the derivative of inverse sine of something. That something must have been x over 3. All right, what should we always do? Just because it's easy to multiply or divide the wrong way, or no, it's just easy to make a mistake. The derivative of inverse sine of x over 3 is what? 1 over the square root of 1 minus the inside squared, then times the derivative of the inside. Does that what we have? That's exactly this line, right? So the derivative of this is this, that one checks. And then all these were equal, so I only need to get to here, right? I don't need to, I could simplify and get to this, but there's no need to. Because it checked here, it checks all the way back to the beginning. So now what? Now I need to plug in my numbers. So it's going to be inverse sine of 3 halves divided by 3 minus inverse sine of 0 divided by 3. So inverse sine of 1/2 minus inverse sine of 0. And we have calculators. So you're supposed to give exact answers. Calculators are good at telling you what the decimals are, and then you can kind of guess what the exact answer was, because it's usually the same bunch of numbers. What is inverse sine of 1/2?
And also 5 pi over 6.
So if you do inverse sine, you need every y coordinate once. Sine links with y coordinates, right? So you need every y coordinate once, which means you throw out the left side of the unit circle. Your answer has to be, when you hit inverse sine on your calculator, how many answers does it give you? It gives you one number, right? That number is always on the right side. It's always between -5 and 2. So what is inverse sine of 1/2 do? That says here's some point y equal 1/2. What is this point? My y coordinate is 1/2. What's my x coordinate? Root 3/2. All right. So I know the point on the unit circle. Now I go a step further. What's this angle?
Pi over 6.
5 or 6. So what is inverse sine? Inverse sine is the angle, so that when you plug it into the sine function, you get the y coordinate. plug pi over 6 into sine, my output is 1/2. What about inverse sine of 0? Yeah, it says my y coordinate is 0, so I'm at 0.10. What angle is that? 0 degrees, 0 radians. So it would be this minus 0, so I get pi over 6. Any questions on that one? Thoughts? It's always easier if somebody else does it. There's a flaw in math. And then you go home, you do the homework, you're like, wow, I can't decide if this looks the same or if it's just that much harder. Yes?
What about number 69?
Number 69. I have one more example I wanted to mention. It's might help on 69 to work on. So let's do the one last example. Alright, let's say velocity of a particle. Of course, that's going to be the next word we'll say, right? Velocity is v of t equal to cosine of t. We want to know what is the net displacement for 0 less than or equal to t less than or equal to pi. And then part 2 is how far did the particle travel? During the interval 0 to pi. So I first want to know what is the net displacement, and then next I want to know how far did it go? What is the distance? What is the difference between distance and displacement?
Displacement includes negatives, but
Displacement can be negative. If I start here and finish here, I move backwards, right? That would mean my displacement is negative. I started backwards from my starting point, or I finished backwards or left is where I started. What about my distance? Distance is always a positive number. I move back, I don't know, like 3 feet. What if I start here, move forwards for a bit, then move backwards and stop right here? My displacement is 0, I stopped where I started, so my net didn't move anywhere, right? Did I travel a certain distance? I traveled that way a distance, and I traveled this way a distance, I can add those together, it's a bigger positive number. Right? How do you go from displacement, or from velocity to displacement?
it's the integral.
Is the definite integral. The area under the curve for velocity is displacement. I think we've kind of mentioned that in passing a few times, but would this make sense? Think about, so we'll do part 1 first. So cosine of t looks like this. So this says I'm moving forwards. I stop because my velocity is 0, and then I move backwards. Why would I want to use area to get my displacement? Let's think about to do a rectangle. So I'm on some interval delta t, and I have some velocity equal to y, whatever.
Is it kind of like how we did it before we had like multiple
Yeah.
rectangles?
Yeah, my distance or displacement. So I move, for delta t units, I moved at the speed of y, right? It would be y times delta t. Why would that make sense? This would be, let's think units, distance over time times change in time. So I'm moving, it's easier if you write units. Say I'm moving 10 meters per second for 5 seconds. How far did I go?
50 meters?
If I move 10 meters in 1 second and I travel for 5 seconds, I multiply, right? If I know how fast I'm moving, my velocity, and I'm moving for delta t units, how far did I go? Y times delta t. So that gives me the area here. So then how do I get my total distance or displacement? Draw all these rectangles, figure out what the area would be for each one, add them all together. That tells me how far I move forward, then how far I move backwards. So it really is, if you want to know the displacement, anytime you want displacement, it is simply find your definite interval. Take my velocity, find the definite interval, that gives me distance. That's one of the big applications we have this unit, or ways to think about this. So then what would this be? What's the antiderivative of cosine? I'm not memorize all of chapter 2.
It's sine.
I mean, most of chapter 2, not all of it. If you teach this every year of your life, you eventually memorize chapter 2.
I forgot what you just thinking.
What is the antiderivative for cosine?
It's sine.
Sine. The derivative of sine is cosine. So we can check that one. This would be sine of t, evaluate from 0 to pi. So sine of pi minus sine of 0. I get what?
0 minus 0.
Yeah. 0 minus 0, so I get 0. Does that answer make sense? We look at this picture again. I move this area, and then I subtract this area. And it's believable that they're the same values. Alright, so my net displacement is 0. Whatever, I know this velocity, it moves forward for a bit, backwards for a bit, it stops exactly where it started. So displacement was 0. Alright, how can I get part 2?
I have a good question for
Okay.
part 1. Since it's a graph cosine, technically, assuming that the graph is technically like consistent throughout, could we just like without doing the rectangle, just like assume that it's 0 because for each interval like up until pi, great. I mean, it's weird to say, but if we like broke it down.
Yeah, I mean, you draw the picture of this clear, this cancels it.
Oh, okay.
But if I'd gone further, it'd be negative.
Yeah.
So you didn't have to account for what were my actual time values.
Okay.
Because they gave me nice ones to work with, yes. Yeah.
But since we're just gonna get 0 plus 0,
Are we?
yes. Because sine of pi is still gonna be 0 and sine of 0 is still gonna be 0.
So you solved the wrong problem. You have to rewrite the problem first. Is the answer, technically the answer for part 2, this comes into play a little bit in the next section also, is this. Can I have a negative velocity? If I'm thinking this distance traveled, velocity is always positive, right? Which means I need absolute value. So I'm not integrating this problem. I'm now integrating this. So can I use the bound 0 to pi? That's where your argument broke down. I can't use only the value of pi and the value of 0. I also have to account for values at pi over 2. Because my problem changed when I went across pi over 2. So what would this actually be? If I want total distance, and I mean formally we say take the absolute value. I could have done it from this picture. What would I do? Find this area,
Absolute value.
and then find this area but make it positive. So it would be the integral from 0 to pi over 2. We agree it's pi over 2? Maybe? Minus the integral from pi over 2 to pi. Why am I doing a minus sign? On that interval, cosine is negative, right? So I need to make it positive. That's put the negative part on the outside. So technically, I wouldn't care. You could go straight from there to there. If you went from this picture to this line, that's correct. You only need to mention absolute value. If you have a picture, you can sometimes write easier solutions because you can see what's happening. Formally, what if we don't know what the graph looks like? You do absolute value. That's really what we're saying. All right. So everybody believe what we have. Okay. I know this is negative, so to add the positive of it. Or what you could say is this. I think this is in the videos. Find that answer, make it positive. So if you don't want to do subtract the negative, just say add, do absolute value. But it's absolute value on the outside, which is different than doing it on the inside. I know this red block is negative. So if this is going to be a negative answer, make it positive and then add. So what would I get? Antiderivative of cosine of t is sine of t. Evaluated from 0 to pi over 2. And then I would add the absolute value of sine of t evaluated from pi over 2 to pi. So what do I get? Sine of pi over 2 minus sine of 0 plus the absolute value of sine of 0 minus sine of pi over 2. What's sine of pi over 2? 1. 1 minus 0 plus 0 minus 1. So I end up with the answer 2. This one's a little bit more precise, right? I had an area of 1 here, an area of 1 here. Instead of doing 1 minus 1, I do 1 plus 1. I moved 1 unit forward, then I moved 1 unit backwards, so my total distance was 2 units. always hidden that you really have an absolute value of there. Once you have absolute value, you have to break it into multiple pieces. When was this positive? When was it negative? I need to account for both. So when you mention this is still 0, this is still 0. I still have this minus this, 0 minus 0, but now I'm adding this number twice. So before I had 1 minus 1, now it's technically 1 plus 1. So it's that hidden number that's in there that we didn't write last time. But I had to account for the fact I went from moving forward to backwards. Here, I didn't care if I changed direction because for displacement, it just works out. It already accounts for changing direction. When you do distance, you have to know when you change direction to account for it. Alright, I'll have you know how it's number 16. What was number 16?
And you assigned it.
Nope. I copied a list provided to us.
Okay, you still making us do it for homework though, either
I
way.
have no choice. I always take different problems. I was annoyed because I had all my homeworks pre-made and they were very different problems than the ones I chose. So the master said it's not. He said I was picked. I mean, it's great. You should all do this. What do we do?
Yep.
There's an easier way to do it and a harder way to do it. So this one wants you just to evaluate this integral. And the flaw is it tells you f of x is this. Then 1 minus x is 4. This isn't fun, but what can I do? So it's going to be this, right?
Wait, you moved the exponent. You moved the exponent.
Yes. X times x to the 8 is x to the 9.
No, the 4.
Yeah, no, I made it easy. So there, right? So what should you do? Basically, I want to use only the power rule. How can I make this only a power rule? Power rule says I need numbers times x's power, right? So I would need to expand this. What would that be? Here's a quicker way to expand it. That would be what? 1 minus 2x plus x squared. And then I can multiply that one out. Once I multiply all that, I can now multiply everything like this, which is just bumping up the exponents. So that part won't be quite as bad. But I would FOIL that out. I don't know much. There's some easier ways to do this, but they would be way less direct. The direct way is one where you just multiply it out. Once I multiply it out, this is going to be basically integral of a times x to a power plus b times x to a power plus c times x to a power dx. Why is that? Why is that useful? Do I know the antiderivative? What's the antiderivative of this? A times 1 over p plus 1 x to the p plus 1 plus b times 1 over q plus 1 x to the q plus 1. And I just keep doing these. So once I write it this way, I only need power. Our goal is to make it where I only need power. Just a little tedious. All right.